Hello everyone, welcome to our lesson on ratio tables. So last time we talked about ratios. Ratios compare to quantities, for example, apples and oranges or butterflies and caterpillars. Okay, now when we talk about equivalent ratios, they are two different ratios, but they describe the same relationship. So the easiest way to think about this is think of equivalent fractions. So 1/2 is equivalent to 2/4, which is equivalent to 3/6. Okay. If we simplify equivalent ratios, you would end up with the exact same ratio. So if we had 2 to 4 is equivalent to 3 to 6, 2 to 4 simplifies to 1/2, 3 to 6 simplifies to 1/2. So the simplified versions have the same ratio. Let's go ahead and expand on that. So if we're given a ratio and we want to write three equivalent ratios, again, the easiest way to do this is through writing equivalent fractions. So for every 8 crackers, there are 6 slices of cheese. So I'm going to write crackers over cheese here as a way to organize things. So for every 8 crackers, there are 6 slices of cheese. Well, what I can do is I can simplify these to get another equivalent ratio, and we can say for every 4 crackers there are 3 slices of cheese. And then maybe I want to scale that up. Multiply both by 5 to get an equivalent ratio of there are 20 crackers for every 15 excuse me, slices of cheese. And maybe again, go ahead and scale up. Let's multiply by 10 maybe. And we get 200 over 150. So for every 200 crackers, there are 150 slices of cheese. Now if I went and simplified 8 over 6, 4 over 3, 20 over 15, and 200 over 150, they would all simplify to 4/3. And that would show me that they are all equivalent. A lot of times Big Ideas likes us to write our ratios as colon or using the colon format. So we could say 8 to 6 is equivalent to 4 to 3, which is equivalent to 20 to 15, which is equivalent to 200 to 150. All right, B here we have 12 red marbles for every 16 pink marbles. So we have red marbles over pink marbles. We have 12 red marbles for every 16. I always like to simplify as my first step. It makes life so much easier. So I could say for every 3 red marbles, there are 4 pink marbles. And now maybe I want to double those to create another equivalence. So I could say for every 6 red marbles, there are 8 pink marbles. And then take an easy one. For every 60 red marbles, there are 80 pink marbles. So all of these are equivalent. If we simplified each of these ratios, they would all simplify to 3 to 4. All right, so go ahead and try one on your own here. We've got for every 10 oranges, there are 20 apples. All right, so I came up with 10 to 20, 1 to 2, 2 to 4, 200 to 400. You might have come up with many different ones because there are an infinite number of equivalent ratios that you could come up with. All right, so let's go to the next step. So we're used to writing these equivalent ratios. Let's actually put them in a different format. We can actually organize our work into a table, oranges to apples. So we have 10 oranges to 20 apples. Well, we could also say, if we look back here, that is equivalent to 1 orange to 2 apples. These are equivalent. And then we had 2 oranges to 4 apples, and 200 oranges to 400 apples. So we're just taking our fractions, our equivalent fractions, and we're organizing them in a nice table here. Now notice that each column creates a ratio that simplifies to the same value. So if you simplify 10 over 20, you get 1/2. If you simplify 1 over 2, well, that's just 1 over 2. 2 over 4 is 1 over 2. 200 over 400 is 1 over 2. So we know these are all equivalent because they all simplify to the same ratio or fraction. All right, we can use our knowledge here to actually find missing values in tables. So to find missing values, we want to use multiplication or division because we want to think about equivalent fractions. Again, all columns are going to have the same simplified ratio. So if we have a ratio of dogs to cats, and we have a 12 to 16, we want to find out how many cats are there if there are 3 dogs, or how many dogs are there if there are 8 cats, and how many cats are there if there's 21 dogs. So the idea is to try and find the missing ratio. So I'm going to try and color code this a little bit so that it'll make things look a little nicer. Alright, so how I like to think of this is, let's look at these first 2 columns. I have dogs to cats is 12 to 16, and I know I have 3 dogs, and I want to know how many cats. Well, what can I do to go from 12 to 3 using multiplication or division? We're just creating an equivalent fraction. Well, we could divide by 4. Now, whatever I do to the top, I have to do to the bottom. 16 divided by 4 is 4. Okay, so for this one we have 4. And how I show my work, I could show my work as a fraction here, or I can show my work right on the table. And how we do it on the table is to draw these little arrows with what operation we're doing. So we're dividing by 4. Alright, now the nice thing with these ratio tables is all of these columns, they're equivalent to each other. So when I'm trying to figure out this column with 8 cats and how many dogs, I could either use the 12 and the 16, or I could use the 3 and the 4. So for this one, I'm going to use this 12 and the 16 because I see that that's divisible by 2. Okay, you might use the 3 and the 4. You could see you can multiply by 2. Well, let's see what this looks like if I use the 12 over 16. So if I have 12 over 16 equals how many over 8? I'm going to change my color to green to make it more readable. So I know from 16 to 8 I can divide by 2. So then I have to do that to the top, and I get 6. So for every 6 dogs, there are 8 cats. That's equivalent to every 3 dogs, there's 4 cats, and 12 dogs, there's 16 cats. Again, I can show this on the table by drawing my arrows here. And I didn't give myself a lot of room, but I think you get the idea here. Now notice, if I went from 3 to 4, I could have done also times 2. 3 times 2 is 6, and 4 times 2 is 8. So that was another option that I had. Alright, last but not least, we need to get to 21. Now there's no good way to go from 12 to 21. There's no good way to go from 6 to 21, but there is a good way to go from 3 to 21. So if I have 3 over my 4 here, and that is equal to 21 over something, I know I can multiply 3 times 7, so I have to do 4 times 7, and that gives me my 28. So for every 21 dogs, there are 28 cats. And again, I can show my work on the table by doing times 7 and times 7. Now I do kind of like writing them as fractions because this table gets kind of messy with all these arrows everywhere. But I think you get the idea. Okay, so go ahead and there's a couple on your own, so give this one a try. Alright, so there are the equivalent ratios, and one more. Give those a try. And there are the equivalent ratios. Okay, so there's more than one way to do these problems. Again, in this case, to get this 15, I did 5 times 3 is, I'm confusing myself. So it would be 20 times 15 is 300, 1 times 15 is 15. So again, you can go from any one column to any other column because they are all equivalent. All right, that'll do it for today.